All right, so we're going to expand our view now from what we've done before. I want to introduce another piece of terminology. We've used this before, but this is the category we've been working with so far. You'll notice when we solve this group of equations, sine theta equals 0, cosine theta equals 0, sine theta equal 1, cosine theta equal -1, all those in this, where we were using the graphs to solve the equations. You'll notice all the solutions were things like 0 and pi over 2 and 3 pi over 2 and pi. The solutions were all quadrantal angles. Quadrantal angles are angles that lie on the axes when they're in standard position. If the equation in question is quadrantal, that's the first dividing line. The quadrantal angles you can solve using the graphs. Anything that is non-quadrantal you solve using either these triangles or worst case scenario you solve with a calculator. All right? So, let's talk now about the non-quadrantal. So that will look something like this. It can't be where you're going 0, 1, or -1. But it will be things like this. Suppose we have sine, and instead of theta, I'm going to use maybe sine of x, is equal to, oh, let's say 1/2. Or we could have cosine theta, or cosine x. I'm switching, it doesn't matter the variable we pick, x or theta or t or z or y, what doesn't matter. I'm cosine of x now. Cosine of x is now square root of 3 over 2. Or we could have sine of x is 1 over the square root of 2. Or we could have tangent of x is equal to -1. Let's suppose this is negative root 3 over 2. That could be a negative number. So all of these fall into this non-quadrantal category. It is not this non-quadrantal. These require working with these triangles. All right, so I want to get rid of these and gain myself some space. I'm just going to rewrite these over here. So I have sine of x equals 1/2. I have cosine of x equals negative square root of 3 over 2. I have sine of x is equal to 1 over the square root of 2. And we have tangent of x is equal to -1. And now let's get rid of this so we'll get some more space to play with. And we'll take a look at each of these in turn. All of this, every piece of it, is something you know how to do already. That's why this is the culmination of everything we've done the whole semester. Everything has been aiming toward this topic. All right? So keep your wits about you. All you need to do is get your ducks in a row and keep your wits about you, and you should be able to get through this without too much trouble. The key is quadrant check, which uses this, and then reference angle, which uses this. Now, a common error students make is they do reference angle, but they forget the quadrant check, or they do the wrong. So, here it is. This is your memory device. Quadrant check, reference angle. Which one happens first? Which one happens first? The answer is it's alphabetical. Quadrant check, Q comes before R. Quadrant check comes before reference angle. It's not strictly speaking required. It's not really strictly speaking required, but if, in my experience, if you don't do the quadrant check first, you forget to do it. So it's alphabetical. Quadrant check first, reference angle second. Quadrant check first, reference angle second. Here's what that means. So we're going to do quadrant check on, let's solve this equation. Sine of x equals 1/2. Step 1, quadrant check. Here's what that means. When we're doing a quadrant check, the fact this is 1/2 is irrelevant. All we need to know is that is a positive number. That is a positive number. When we do this next equation, that is a negative number. When we do the next equation, that's positive. When we do the next equation, that's negative. All we need to know is the signum. Is it positive? Is it negative? That is a positive number. The quadrant check is this. Check says this. When is sine positive? In what quadrants is sine positive? You know that. In what quadrants is sine positive? Sine is positive in quadrants 1 and quadrant 2. So write that down. Quadrant check. There's going to be a quadrant 1 solution and a quadrant 2 solution. So all you need to know is that positive or is that negative? It's positive. So when is sine a positive number? Sine is positive in quadrant 1 and quadrant 2. Now here's the next piece. The next piece this is very important. Once you've done the quadrant check, there actually is a little plus sign in front of here, it's just we don't write it because we assume it's positive. But once we've done the quadrant check, you may ignore the signum. You may ignore the signum once you've done the quadrant check. The positive or negative has been taken into account. In particular, pretty soon when we solve this equation, we're going to do the quadrant. So here, let's see. What's the quadrant check? When is cosine negative? When is cosine negative? When we do this problem next up, right? When we solve this problem, when is cosine negative? This is where it's positive. So cosine is negative in quadrants 2 and 3. So there's going to be a quadrant 2 solution and a quadrant 3 solution. Once you've done the quadrant check, you may now ignore this negative sign. It has done its part for king and country. This little negative sign goes off into the country to retire. So once you do the quadrant check, you ignore the signum. You're working only with the numeric value itself. Quadrant check, quadrant 1, quadrant 2. Next is reference angle. I'm going to run out of space here. Reference angle. All right? We know we have sine is 1/2. Sine is 1/2. Now you use the number, not the signum. Now, what do we know about sine? Sine is opposite over hypotenuse. Which of these triangles deals with 1/2? It's not very hard to figure which triangle we're working with. This doesn't have a 1/2 in it. This one does. This has a 1/2 in it. It has a 1/2 in it. All right? So, we're using the 30, 60, 90, or pi over 6, pi over 3, right? So, reference angle. We need to know from which of these angles is opposite over hypotenuse. We want sine, which is opposite over hypotenuse, to equal 1/2. Sine must equal 1/2. Opposite over hypotenuse must equal 1/2. And all you do is just try one. If it works, wonderful. If it doesn't, try the other one. Try this one. From this angle's perspective, what is opposite over adjacent? From that angle's perspective, opposite over adjacent is 1/2 over 1. Opposite over adjacent is 1/2. Why did I know to do opposite over adjacent? Because I'm solving sine. I want opposite over adjacent to be 1/2. Yes, 1/2 divided by 1. Yes, that is 1/2. This is the angle. That's the reference angle I'm looking for. And so we can say x reference, not x itself, x reference is that angle. We are in radians. We're solving. We are in radians. You can think 30 degrees all you want, but you need to write pi over 6. Think 30 degrees all you want, but we're writing pi over 6. Reference angle is pi over 6. The only thing that's left to do is take that reference angle, put it in those two quadrants, and you're out. There's a quadrant 1 solution. In quadrant 1, the reference angle is the angle. So our quadrant 1 solution, x is pi over 6. Quadrant 2, this is pi over 6. We want that angle. In quadrant 2, to find the angle itself, you take pi and subtract off the reference angle. So we want pi minus pi over 6. That is to say pi minus pi over 6. That's 6/6 minus 1/6, 5 pi over 6. I realize the first time through it feels like you're just juggling jello, but you'll get better at this as you go. Do each little piece one bit at a time. All of these pieces are things you know how to do. So the next couple videos, we'll go through each of these in turn and several others like it so that you get more and more practice and get more and more comfortable with this.